Welcome back to Math 104. We have already found the probabilities of two of our four basic regions inside this Venn diagram based on the given information and based on working our way outward from the probability of the intersection region. Our task is, for each of the other two basic regions of this diagram, find the probability of the event it represents and write that event in terms of unions, intersections, and/or complements. Let's first look at this region inside the N circle but outside the O circle, the event that the donor has a negative blood type other than O. Now, the information given to us at the very beginning included the fact that the probability of N as a whole equals 0.16. That means that the probability of N but not O must be 0.09. Why 0.09? Because 0.09 is the result of taking the 0.16 total probability for the N circle and subtracting off the 0.07 that has already been accounted for. How about the outside region? We must not forget the outside region. It too counts as a basic region. There is an event here that matters. Here we need to observe that 0.38 plus 0.07 plus 0.09 is all the probability that's already been accounted for. There is a 0.54 probability overall that our randomly selected donor falls into one of these three categories we've already studied. That leaves 0.46, which is 1 minus 0.54, 1 minus what's already been accounted for. That 0.46 must be the probability of this outermost region. Now, how do we write these in set notation? This region right here, that is outside the O circle and inside the N circle, is just O complement intersect N. There is nothing else I need to write to specify that this is the region I'm talking about, outside O and inside N. What about this outermost region? How can we write it? This region is outside the O circle and outside the N circle. Writing simply O complement intersect N complement is enough information to specify that this is the region we mean, nothing more and nothing less. Now we're ready for some important observations. Observation number 1. Each basic region of the Venn diagram can be represented as an intersection of the given sets of the given events, O and N, or as an intersection of two sets, an intersection of two events, where one or both of those events is the complement of O, or the complement of N. So each of these basic regions is represented as a two-way intersection. Important observation number 2 is that any two of these basic regions represent mutually exclusive events. There is no overlap between this basic region and that basic region because that's just what basic region means. The O circle as a whole is not a basic region. The O circle as a whole overlaps with the N circle as a whole, but those are not basic regions. This basic region has no overlap with that basic region, which has no overlap with that basic region. Important observation number 3. If an event contains two or more basic regions of the Venn diagram, it can be written as a union of the events corresponding to those basic regions. For example, O union N. O union N in the diagram is comprised of three basic regions. These regions are O intersect N complement, O intersect N, and O complement intersect N. In fact, once we've written the probability into each basic region, we can find the probability of O union N by adding up the probabilities that correspond to these three basic regions. But wait a minute, I thought O union N is just O union N. How could O union N also be some other notational thing? That is important observation number 4. There are different ways to describe the same event in set notation. There are different ways to describe the same event using unions and intersections and complements built from the two given sets O and N. Students sometimes find this surprising, but it's not really different from saying that 3 times 4 represents the same number as 2 times 6. They're both equal to 12. They're both equal to the same thing. Here too, we have two different ways of representing the same collection of outcomes. Having made those important observations, now we're ready for the following. Consider the event O union N complement. Notice the difference between putting a complement sign over a union and putting the complement sign over a single letter. What this symbol means is that we are first taking the union of O with N. So O union N is its own thing. And then whatever O union N is, we then take the complement of it. It's very much like order of operations in algebra. If I have a sum of two numbers enclosed within parentheses, and then I have a negative sign in front of the parentheses that instructs me to carry out what's inside the parentheses first, and then apply the negation. That's what's going on here. First understand what O union N is, and then take the complement of that. Our task is to find the probability of this event, to describe it in words, and find a different way of writing it in set notation. This is actually not so bad. We know what O union N is. It's everything inside these three basic regions. So what's O union N complement? It's everything else. Everything else means just the outside region, and we've already computed its probability, namely 0.46. How do we describe this event in words? This is where it's very helpful to have drawn and shaded the Venn diagram, instead of trying to write the verbal description directly from the set notation. We see from the shaded Venn diagram that this is the event that the donor has neither type O nor a negative blood type. Finding another way to write this event in set notation is also not so bad, but only because we have already drawn the shaded Venn diagram. That makes it much easier. We see that we've already thought about this event. This is the event O complement intersect N complement. This event corresponds to one basic region of the Venn diagram, and we know how to describe single basic regions of the Venn diagram. Behold, we have discovered that O complement intersect N complement is the same event as O union N complement. Before going on to the next video, consider the event O intersect N complement. Find its probability, describe it in words, and find another way to write it in set notation.